A student repeats the experiment with a modern apparatus that has lead spheres of unequal size, 25 millimeters in radius, 100 millimeters in radius. The large sphere had a radius of 100 millimeters and a mass of 47 kilograms. The small sphere had a radius of 25 millimeters and a mass of 0.73 kilograms, right? So this is going to be, what we're going to do for this is we're going to use force of gravity as G m1, m2 over r squared, right? The r you're going to use is going to be 100 millimeters plus 25 millimeters, right? So notice, there it is, right? But convert those to meters, right? So it's going to be what, 0.1 and 0.025 meters, right? But convert those to meters. That's your R. This is your mass 1. Here's your mass 2. Okay. Don't expect it to be a large force because it's going to be, forces typically, you know, are very, very small. Okay. So that's the first part. Hopefully that's a slam dunk for you, but you know, there it is. Just be careful when you do this. Literally what you can do is you can go 100 times 10 to the minus third plus 25 times 10 to the minus third and let your calculator do the proper conversion for you. Okay, because milli is just 10 to the minus third. And then the rest of B says, the student repeats Cavendish's experiment using lead spheres of twice the radius, right? Well, that's going to affect your distance, right? So since the force of gravity is what, gm m over r squared, right? You've got the small ones, right? And then you've got the big ones. Okay, r is going to be twice as big, right? Okay, so we're going to get g, and then in the denominator we've got 2r, right? If we double the radius of the spheres, then the distance separating them will be twice the distance it was before, right? Okay, and then if you double the radius, ultimately the size of these spheres, the mass is going to be proportional to their size, and the volume of a sphere is 4/3 pi r cubed, right? And so the mass is going to be proportional to the volume. And if you double something that's cubed, whoops, 2r to the third is going to be 8 times the mass, right? Whoops, 8 times the mass, okay? And so, but both masses are going to increase by a factor of 8. So 8m1, right, times 8m2, okay? So figure out, what is this factor? What is the factor of g times 8 times this mass and 8 times that mass and 2 of that, right? I think you can figure it out, right? So literally go 8 times 8 divided by, 2 squared, right? Okay, that'll be the change. It'll be more by that amount, right? Okay, they like to do that. They like to give you things where you figure out some proportion, okay? Well, good luck with that.